Greetings everybody, welcome back, and today we're going to talk about tires. I will do my best to spare you of the dad jokes and the tire puns. I'm sure you can come up with a few on your own. Tires are the first part of our suspension system. They connect the vehicle to the ground, and in order to keep the vehicle handling safely and reliably, tires need to be maintained for optimum tread wear over their life, free of any flaws or defects, and they need to remain in constant contact with the ground. We'll get into more of the systems that play into this role of the tires staying in contact with the ground, but today we're going to go over more things like tire construction, tire servicing, and general tire maintenance and servicing. Tires are constructed in layers, and the first layer that's made on a tire is the inner layer. This is the airtight layer. The other layers are permeable to gases and other things. They don't seal out the size of an air molecule. The inner liner portion of the tire is important to remain intact for sealing purposes. So we must pay attention to this when it comes to repairing tires and servicing them for a patch or a hole. Now you can see some of these diagonal running lines through the tire, and in the middle there's kind of a seam, and there are other spots like right here where some of these plies and layers are folded together. As the tire construction process occurs, there will be overlapping of the different layers, and these come into what's called the major splice. The major splice is not a defect, it's present on all tires, and some are more pronounced than others, but if you feel it, you can actually feel kind of a bulge when you pass your hand over that. It's important that tires are balanced effectively so that the rotating mass of the tire doesn't wear on one part of the tread more than the other, and then that can amplify into suspension movement. The sidewall of the tire is the part of the tire that carries the weight and the load of the vehicle. It is this rounded area right here, and it is the space between the tire tread, which is on the contact side of the tire, which is opposite from this surface right here. So the contact portion is right here. The sidewall is curved, and it's supposed to deflect and flex. So it is not as rigid as the tread is. This is where we get the suspension component of the tires. This offers the give on small bumps and cushions bumps and road hazards from damaging the wheel and potentially other parts of the suspension system. The part that engages the wheel and seals is the bead. If this were cut right down the cross section of the tire, you would see steel cables woven in a cord all the way around the bead, and then that bead is covered in layers of rubber. That bead cannot stretch. This is a rigid piece that does not change its dimension. And we'll talk more about this when it comes to mounting tires and what makes that possible and how to get them onto the bead flange, which matches the same diameter as the bead. So these have to slip onto the inside of the bead flange on the wheel in order to mount the tire and create an airtight seal. The tread portion of the tire is in contact with the road, and any of these lines that you have in a tire, any of these grooves and sections, will either be lugs or sipes. The siping is where there is little to no gap in between, but there is maybe like a slice mark. And you can see some of that right here. This would be siping. This would be siping. This would almost be a large siping, not quite a lug. And this is to provide traction for the tire on different surfaces. Some tires are more tailored to dry condition operation, and some are conditioned more for wet operation. So the tire tread design and the compound that makes up the tire tread is going to aid in traction for the vehicle on the ground. Now these compounds can be softer, they can be harder. They can be tailored for cold climates or hot climates. And depending on what the use of the tire is, if it's a general all-purpose, it's going to try to cover, the manufacturer of the tire is going to try to cover a wide range of varying conditions for that tire to be used and reliable in. This also means that it's not going to perform exceptionally well in any one of those categories. That's when more specific use tires will come into play for racing applications, winter weather, dry weather, summer weather, dirt and off-road, wet, rainy, snowy, icy, all those different conditions. So manufacturers will make tires that tailor the tire towards certain conditions. For the most part, the all-season radials are going to be a universal tread pattern, tread design, and be made of a more versatile compound of rubber for performance in all conditions. Across the tread of the tire, right on the edge is the shoulder of the tread design, of the tread pattern. This right here is the shoulder. The wear on the tire should come out to the shoulder and not go beyond the shoulder. So our wear surface is just the flat contact area around from shoulder to shoulder. This also is an indication of where it's okay to patch a tire. Anywhere at the shoulder or beyond is not an acceptable place to repair a tire for damage. Across the tread of the tire, in these grooves, we can measure the tread depth of the tire. As tire tread depth decreases over time with wear, the performance of the tire will decrease once it reaches a certain tread depth. That has been determined by the universal tire quality grading system as to when that is to occur. Standard is 2/30 seconds of tread depth or less is no longer safe operation for a vehicle. That may vary if the tread was considerably deeper on, let's say, an off-road tire or a flotation tire, which we'll get into in a little bit. Tread depth gauges are a pretty simple tool. They have a plunger and a surface to measure against, and then on the side there are different measurements, and they are stepped, and one half of the plunger piece is in designations of 30 seconds and the other one is in millimeters. And I know this is blurry, but the yellow scale is in millimeters, and there is an mm at the top, and then the white scale is in SAE, or 30 seconds of an inch. Typically, tires will be measured in the 32nd of an inch range, and the way to use this tool is to push the plunger down, go to the tire tread depth surface, go to a low point, and wiggle that into place, and then reading whichever line is at the top of the part that you hold. So as you rotate it around, since they don't want to crowd the measurement surface, that's why it has different faces on it, rotate it around until you find the line that lines up with that part of the body. In this case, it is 4/30 seconds. So on this face right here, the bottom number, which you can't read, and I apologize for that, is a 4. So this tire is 4/30 seconds tire tread depth. So it's getting low. It's going to be due for replacement at some point. Molded into the sidewall are some key bits of information. Some of these include the manufacturer and the model of the tire, and then we get to tire size. The tire size breakdown is in the text. This one is a 215 55R16 93H, where we have our cross-section width, or the width of our tire tread, and this is in millimeters. Then we have our aspect ratio of 55. You could think of the aspect ratio as 55% of the tire's width. It's the width across the tire tread compared to the height of the sidewall. And the height of this sidewall, according to the 55, is just over half the width. So just over half the width here. This would be half from here to here. Just over that would be about that much, and that's our sidewall. So the aspect ratio is what we use to identify how tall the sidewall of the tire is. The R stands for radial construction, and that has to do with the steel cords that are inside the tire, or the belts. As the tire tread wears, if it wears unevenly, these belts can be exposed. and they are below the tread surface. They should never be exposed. If they are exposed, they can cause injury by puncturing your skin, so wearing nice tough gloves when working with tires is always a good idea. Leather is probably best since those cores would not penetrate through the leather. And the 16 is the diameter, or the inside diameter for the wheel size that it's supposed to mount to, and it designates the diameter of the bead. 93 is the load rating, and H is the speed rating. When a tire is repaired, it can accept up to 2 patches or plugs during its serviceable life. If it has more than 2 plugs or patches in it, it is no longer usable for the road and should be discarded and replaced. This tire is certified approved by the Department of Transportation, and the date, if you can find the date on the tire, it may not be on both sides of a tire, but at least on one side of the tire, on one sidewall, there will be a 4-digit number. This one is 3815. What that means is that this tire was made on the 38th week of 2015. The 38th week of the year falls sometime mid to late September, or the second half of September. So we know by reading this date that this molding was cast, or this tire was manufactured and left the factory sometime towards the middle end of September in the year of 2015. Tires have a serviceable life recommended within 9 years. So by 2024, this tire would need to be replaced if everything else was otherwise perfect on it. Not to say that everybody's replacing their tires at the date that they're due, and I'm guilty of this myself. So it's a guideline. It should be recommended. Our responsibility as professionals in the industry is to recommend replacement, and then it's up to the customer whether or not they want to replace the tire. This is an example of a winter snow tire, studless snow tire. This actually has a casting in the sidewall designating the direction that the tire is supposed to go or rotate. Also visible here is our match mount location, designated by the yellow dot on the sidewall, and it's lined up with the valve stem on this wheel. This is a light truck all-terrain tire application. And look at that, full floating axle. On this one, may not be easy to see, but there's an LT 255 75 P16, and this LT stands for light truck. It's designed to work with the load carrying capacities of a light truck vehicle or a light truck chassis. On a lower profile tire, you can see the aspect ratio is much different. 245/40 R18. And these would be an asymmetrical tire, but non-directional. So they can rotate in either direction, but when mounted to the wheels, this has to be mounted facing the outside. Another type of tire is a flotation tire. These are going to be more common on off-road applications. These can be of varying sizes across different vehicles. This is designated in the size right here, 33 by 12.50 R15 LT. We know that LT stands for light truck. R is for radial construction, 15 is our bead diameter, and this is 33 inches in diameter by our tread width, 12.5 inches wide. So this is our flotation sizing designation on a flotation tire. Flotation tires may be present on a vehicle that is exposed to off-road conditions somewhat frequently or periodically. These tires often can be aired down to below the manufacturer's recommended tire pressure in order for it to absorb more of the bumps in the roads or in the surfaces that it's driving on, and to help the tire tread form around those obstacles and help to provide more grip. Flotation comes from them being able to stay afloat on surfaces like sand, mud, dirt, snow, and gravel type of surfaces. Tires rated for use in snow and ice will often have a combination of tread design that helps to mitigate snow and slush and water out to the outside of the tire so it doesn't get trapped underneath the contact surface and lead to hydroplaning. And in between, on the lugs, there will be more siping. The rubber compound that is on these types of tires will often be softer, almost sticky, and are designed for optimum grip in cold climates. As temperature decreases, most tires' coefficient of friction is a little harder as temperature decreases. These are designed to remain soft and grippy in cold and snow and ice conditions. The siping in between on each of these lugs acts as little bits of grip. They improve traction, and what happens is on those treads in between the sipes, those little pieces can flex one way or the other, providing a little bit more contour with the road surface. Now, as these lugs are rolling around the tire on the contact patch of the tire to the ground, as these lugs pass over that contact patch with the vehicle weight on the tires, they're going to be rubbing against each other. And the more rubbing against each other they have, the more heat they generate. Heat is the #1 wear item for tires. So if we can keep the heat down, we can make tires last a lot longer. Now, these are made for ice and snow conditions, cold climate. If these are run on a hot day at high speeds, that friction is going to generate enough heat to ultimately ruin the tire tread, and the tire may start coming apart due to the excessive heat generated from the friction. There may be different colored dots lining the sidewall of the tire. Typically they're going to be yellow or red. Sometimes you'll see white, blue, purple. The only ones we want to pay attention to, or that we will pay attention to, are the yellow and the red. And the red dot stands for the tire's uniformity method of match mounting to the wheel. Match mounting is using the construction of the wheel, and where there may be a slight imperfection but still within tolerance, and matching that to the in-spec tolerance irregularity on a tire. So it can be done either with uniformity or with weight. Weight has to do with the density of the tire changing around the surface of the tire, and uniformity has to do with our dimensions of the tire compared to the dimensions of the wheel. The red dot on the sidewall should be matched to a notch or a marking on the wheel. The notch or the marking on the wheel is going to designate where the radial runout of that wheel is at its minimum. The radial runout is the distance from the edge to the center of rotation changing. So that runout of the tire, where it's at its maximum, should be matched to where the wheel is at its minimum to help compensate for those irregularities. A yellow dot is for weight match mounting the tire onto the wheel. The valve stem is usually the heaviest point of the wheel when the wheel is spinning. The match mounting point that is yellow on a sidewall indicates the lightest area on the tire. So matching the lightest portion of the tire to the heaviest portion of the wheel should help cancel out enough, or to the best of the abilities of the tire mounter, where that balance is going to occur. So less weight needs to be used once we start balancing the wheel and tire assembly after mounting the tire on there. That's why on the Honda CR-V that I was showing you an example of with the Michelin snow tires, the yellow dot lines up with the valve stem of the wheel. So if there's a red dot, then it needs to be match mounted to the portion of the rim that is indicated by a mark or a notch on the wheel, which most wheels don't have. So red dots are hard to use. Yellow dots are a little bit more easy to use for match mounting a tire. So the yellow dot would line up with the valve stem. And this isn't for every case, this is for most cases. As the tire rotates on a vehicle, it's going to come in contact with the ground in that location, and then that's going to continue revolution all the way around until it comes back to the ground again. Each time that part of the tire is contacting the ground, the weight of the vehicle is being supported by the sidewall. And this is going to cause flexing in the sidewall. When we were talking about the siping, improving traction but also increasing friction on a snow tire or otherwise, the sidewall flexing is also going to generate heat. Much like a paper clip, if you bend it back and forth too many times, it's going to break, and that break point will be hot from those molecules being stretched and strained. The same thing happens to a sidewall of a tire. It's important to maintain manufacturer specifications on tire pressure in order to keep the sidewall from flexing too much and generating too much heat, which will eventually lead to overheating the tire and result in tire failure. The maximum load and maximum pressure designations cast into the sidewall of the tire indicate the tire manufacturer's thresholds for this particular tire. This is not specific to the vehicle. Many tires can apply to many different vehicles. So this tire could be on an SUV, or it could be on a mid-sized sedan, or some other type of vehicle. Tire pressure and load, this one says 1,433 pounds, and max pressure at 44 psi, and the metric equivalents next to them. These are specific to the tire, not the vehicle. The vehicle has a tire placard that these specifications should be followed by. The manufacturer is saying that this tire itself should never exceed 44 psi and 1,433 pounds of load. It's going to be less than that for vehicles that this tire applies to. Maintaining an optimum contact patch with the road surface is ideal across the tire tread pattern. The contact patch is ultimately going to be about the size of your palm on the underside of most vehicles or most passenger cars. That's going to increase as the tires are wider on certain vehicles. And something that will contribute to that is inflation pressure. If a tire is underinflated, there's going to be more load on the sidewalls of the tire and they're going to flex. What that's going to do is force the center contact patch of the tire away from the road surface. It will put extra load on the shoulders of the tread, or the outsides, and it will be reducing tread in contact with the center. So an underinflated tire will have excessive wear along the outer edges of the tire. If a tire is overinflated, which is fairly common, both of these scenarios is very common. If a tire has been run overinflated, it's going to push the center out more, which is going to increase pressure on the contact point in the center of the tread and decrease the amount near the outsides. So an overinflated tire is going to show excessive wear down the center while maintaining less tread wear towards the edges. Tire conicity, or the coning shape of a tire, means that the tire will not sit straight up and down due to the tire tread being worn unevenly. If the tire has been loaded one direction with excessive camber, which is the inward or outward tilt of the top of the tire in reference to a true vertical line, if the camber has been out of spec or the tire has developed a scrub and has worn more across one side of the tread than the other, then it will start riding in a cone shape. Tire conicity can lead to a steering pull or a drift that cannot be fixed with an alignment. It would require replacing the tires. Think about the one wheel. The one wheel is an electronic board device that uses one wheel with a foot in front and a foot behind on a platform. And the user uses their balance to lean forward, lean back, and the electric motor senses which way you're trying to go and will propel the operator in that direction. In order to steer the one wheel, it's a small wheel with a tire, and it's quite wide. It's about the width of the board. And in order to steer, the user leans like you would on a skateboard. So if you want to steer that direction, you put pressure on that side of the board and it will turn that direction. If you want to go the other way, it will turn the other way. This is using tire conicity to steer and is a very clear illustration of how that contributes to steering pull. Wheels and wheel design are going to pertain to each vehicle individually, and the manufacturer has designed the wheels around the suspension system to run with a certain size tire, a certain dimension wheel, with a certain suspension geometry. All of it works together to avoid overloading on wheel bearings and steering and suspension components, and to create optimal vehicle handling on the road surface. One thing that all wheels have, you see it on this one, tapers down to this smaller diameter. Same with this wheel. This portion right here, smallest diameter. And this wheel here. This is what's called the well, or the drop center of the wheel. This is what makes it possible in order to mount a tire onto a wheel. This is the portion that the bead is going to rest in while the bead is being worked around the bead flange of the wheel. So let's break down some of the components of the wheel themselves. To make things a little more manageable, we're going to be working with this half a wheel here. A couple dimensions to focus on a wheel are the width of the wheel, which is the distance between the bead flanges. This is where the bead will seat and create an airtight seal. And notice this little lip right here, just behind the bead surface. That bead has to be forced over that lip, and it will seal on the bead flange. And the bead flanges keep that tire from pushing off of the wheel. So bead flanges make it possible to keep air in a tire and for the tires to support the load of the vehicle. The drop center right here is a small diameter that is necessary in order to mount the tire onto the wheel. If this wheel was the consistent diameter all the way across, it would be impossible to mount the tire to the wheel. The valve stem is located on the wheel right here, and this allows air to come into the wheel and tire assembly with the airtight seal, and that air can propagate into and fill the space inside the tire. The mounting flange of the wheel is where the wheel studs or the lug nuts will anchor the wheel against the hub. The location of the wheel mounting flange, the location of that in relation to the center of the wheel itself is going to determine its offset. So offset has to do with this mounting surface plane where it mounts to the vehicle. If this mounting surface plane is directly in the center, the geometric center of the wheel, that has 0 offset. If this plane is moved out towards the outside of the wheel, that's going to be a positive offset. And if it's towards the inside, it's going to be a negative offset. So a negative offset will position the wheel further out on a vehicle, and a positive offset will position the wheel further in on a vehicle. Looking from the outside of a wheel, it's possible to determine close to where the offset is. But on wheels like the one back here for a Jeep Grand Cherokee, the design of the wheel makes it hard to tell exactly where that offset might be. It has to be measured against the mounting flange of the wheel. Looking at the mounting flange of the wheel makes it a lot easier to tell whether or not it's close to center line, positive, or negative. The Jeep wheel here is an example of the most positive amongst these 3 examples. The GMC wheel is also towards the outside as well. That can be determined visually by imagining where the center line of the wheel is. This one may be positive, but it's not easy to tell. This would have to be measured, and in order to know the exact offset, you would have to measure them unless it was stamped into the casting of the wheel. I want to talk about wheel mounting and bolt patterns. Bolt patterns can range in a number of mounting holes they have for each vehicle. This is an example of a 6 lug. This is an example of an 8 lug. And this is an example of a 5 lug. There can also be 4, sometimes 3, sometimes 7. It can vary depending on the vehicle application. The other part that can vary is how far apart from center these are. The bolt pattern is designated by the number of holes and the diameter of the circle that those holes make. When we're working with even number mounting holes, it's a lot easier to determine the bolt pattern. The bolt pattern designates, the first part of the bolt pattern designates how many lugs or mounting holes there are. So in this case would be 6. And then the other part would be the diameter of the circle that those make. And in this case it's 5.5 inches. So the bolt pattern for this wheel is 6 on 5.5, or 6 by 5.5 inches. This circle, this bolt pattern circle, or determining the bolt pattern, gets a little tricky when we're getting to odd numbers. On an even number one, we can measure directly across the farthest mounting holes or lug nuts or wheel studs on a vehicle. We don't have that ability on a 5 lug or a 3 lug. In order to measure this wheel's bolt pattern, we would have to measure from one hole to where that circle would arc between the opposite side 2 lug holes or mounting holes. There isn't an accurate way to do this, but there is a tool that we can use. Typically, you would measure across the bolt pattern as far as possible and get an approximate guess. This tool is called a bolt circle template, and this is for a 5 lug design. And you can see that we have varying distances from center for our 5 lug design. The way to use this is to match it with the wheel or on the vehicle to determine which one matches up. Take, for instance, this wheel hub. In order to find what this bolt pattern is, we would fit the template over it until we determine the correct mounting holes for it. And then on that tool would tell us that this is a 4.5 inch circle. So let's look at one more thing to help illustrate what that concept looks like. Drawn on this pad of graph paper here is a 4.5 inch diameter circle. According to the template, we're sitting on the 4.5 inch measurement. So if we place this on here, lining up the 4.5 inch measurement, so we're looking at this one, this one, this one, this one, and this one. That illustrates how that circle passes through the center of each of those mounting holes or wheel studs. For measuring on this wheel, on an 8 lug, we can go across the center because it's even numbers. Now I'm measuring from the edge of one circle to the edge of the other circle, so the same corresponding edge. It makes it a little more definable rather than trying to hover the measuring tape over the center of the hole. So with this one positioned all the way out towards the edge of one hole and mounted up and measuring to the edge of this hole, we have a measurement of 8 by 6.5, or 8 on 6.5 inches. Wheels can center onto a hub mounting flange one of 2 ways. That would be by centering it on the lugs, so the lug nuts would actually locate the center of the wheel and make it uniform all the way around, so there's no hopping of the wheel as it rotates. Or it will be centered by the hub, meaning this section of the hub. So some vehicles may center their wheels based off of a precision fit between the hub bore and the hub flange itself. Most of them are going to be centered on the lugs. The terms that we use for these, if it's centered by the lugs, it's called lug-centric, and if it centers by the hub, it's called hub-centric. The name implies what it does. On lug-centric wheels, there usually will be a taper or a conical shape on the mounting hole. And that taper is going to match the wheel stud or lug nut taper to mount that wheel on there. So as this is tightened into place and torqued to specification, this taper is going to match the taper in the hole and provide a nice centering characteristic for that wheel. There may be a gap on the inside of the hub because it's not important that it fits directly on the hub. Other type of lug-centric would be the type that use a flat shoulder. This type is more common on wheels that are made of softer material or softer alloys like aluminum or other composites or magnesium. If the wheel had a taper on it and was made of soft material, it may not be able to distribute that load evenly and would end up deforming at that contact. So to help provide a little bit more strength for a lighter alloy wheel, softer material, there may be a shoulder, and this is a pretty small shoulder, so this shoulder could actually be a lot longer, but then it allows that material to rest on a more robust surface. And that is typically the way that hub-centric wheels mount as well. This would also require that a washer is placed to help distribute that load evenly where the wheel is torqued. So shoulder lug nuts can be either lug-centric or hub-centric. Here's an example of a wheel stud that is not a lug nut, but it includes the mounting surface for the wheel, and it doesn't spin on a wheel stud. This wheel stud fastener does both the job of the wheel stud and the lug nut all in one piece. A lot of people don't like this type. It's common on a lot of European vehicles, some American vehicles, some Japanese. But oftentimes people are frustrated when they see this type because it's hard to hold the wheel in place. Once you get to work with a few vehicles, I've grown to appreciate these a little bit more, because damage can occur to lug studs or wheel studs and lug nuts and make it labor-intensive process to replace or repair damaged components. Whereas this one threads into a threaded hole, and if this needs to be replaced, it's all one piece, can be replaced and install a new one. This lug nut example is an example of a wheel lock, and it doesn't have a standard hex shape to drive it on. Instead, it requires the use of a wheel lock key. So that profile inside of there matches at some point of the rotation, matches the wheel lock. And these are used to provide an anti-theft or theft deterrent feature to certain wheels. Lug nuts can be hollow all the way through. So it's a hex drive, has a taper on it. This would be the type used to mount this type of wheel. And that taper fits right in there, and then the external threads on this would thread on the hubcap or the wheel cover. So tapered fit, nice and snug, lug-centric.